Hello everyone, this is Mr. Garcia, and in this video lesson we are going to learn how to use graphs and tables to solve systems of equations. Okay, so a system of equations is a set of two or more equations containing two or more variables. On the graph of the system of two equations, the solution is a set of points where the graphs intersect. A point is a solution to a system of equations if x and y values if the x and the y values of the point make each equation true. So when solving linear systems of equations, you're graphically finding intersections of lines for two variable systems, and there are three possible types of solutions, and I'm going to go over that next. So it is possible that when you graph two lines, they will intersect at one point, okay? And this is called the point of intersection. Now, this point will be a solution to the system if when you plug in the value of x, which in this case is -2, and the value of y, which is +1, if that gives you a true statement, then we say that this is a solution to the system of equation, which means it's the point where the two lines intersect. However, it is also possible that you might have two lines that are parallel. Okay, so if that's the case, then the lines are not going to intersect, so there is no solution to this system. And the third case is, what if you have the same line on top of the other? So in this case, we have two lines that are the same line, so they intersect at every point along their length. This means the solution is it's every point on the whole line, and we say there are infinitely many solutions. Okay, so we have some fancy terms that I'm going to go over next. So if we say that a system has at least one solution, which is the case here, then we call this system a consistent, okay? Consistent system of equations. What happens when there is no solution, meaning the two lines don't intersect? So in this case, they're parallel. Then this we call an inconsistent system. Okay, so this one is inconsistent because there is no solution. What if you have infinitely many solutions? Then as long as you have at least one solution, this system is also called a consistent system. However, this one has another name since it's consistent and it only intersects at one point. This is also called independent. So it's a consistent and independent system, okay, because it only intersects at one point. This one, however, this one here is dependent. And think of this as two lines following the other, okay, so they're on top of each other, so it's kind of, they depend on each other, so they can be separate at any time, okay. Okay, so next we are going to use the graphs to solve the system of equations. So in this case, we have a system because we have two equations. Now, the only thing is that these equations have to be in slope-intercept form. And as you can see, this one has y plus x. So we need to bring this x to the right-hand side. So when we do that, that means we're going to subtract it, right? So subtract x from here and also from here. And then this is y equals -x plus 4. So what I did was I brought this equation here. So now I'm ready to graph. Okay, so I'm going to graph this line here. So this has a y-intercept of 4. So I'm going to plot the y-intercept first. So this is 1, 2, 3, and 4. This is where the line is going to cross the y-axis at 0, 4. And then the slope is a negative slope, so it's 1/1. So the line will be coming down from left to right. So if I go down 1, I go right 1, and I can get as many points as I want here. But 3 should be enough for me to be able to plot this point. Well, actually, I'm going to continue going. Okay, I'm going to do a few more, and you'll see why in a moment. And let's see. So let's stop right there. So let's go ahead and connect the points so we can see or sketch the line. So this is this equation, and now let's do the second equation, and I'm going to use a red pen for this one. So this one has a y-intercept of 2, 0, x is 0, y is negative 2. And then from here, this has a rise of 1 and a run of 2. So up 1 over 2, up 1 over 2. And as you can see, that's where the two lines intersect. So by looking at the two graphs, we can right away tell what the solution is. Okay, so the solution to this system of equations is where the two lines intersect. The question is, what is the value of y and what is the value of x at the point of intersection? And the answer is 4, 0. Okay, now I'm going to check my answer. Okay, so if I'm saying that this is a solution, I'm going to plug in wherever I see a y and an x, I'm going to plug in these values. So y is going to be 0 equals, this is going to be negative 4 because that's the value of x. And okay, and then I'm going to add 4. And as you can see, this is 0 equals negative 4 plus 4 equal to 0. So that means it is a solution to the first system, to the first equation, but it's going to be a solution to the other equation also. So I'm going to do the same thing with this one here. Okay, and I'll do this one with blue. So then this one is going to be 0 equals 1/2. The value of x is 4. And then we are going to subtract 2 on this one. Okay, so then this is equal to, so this is 0. And this is half of 4. That's going to be 2. And 2 minus 2 is equal to 0. So as you can see, this is a solution to the system of equations. And because this is a true statement. Okay, so we can see it on the graph, and we can also plug in the values to just verify that this is an actual solution to that system. So let's go on to the next example. So in this case here, this problem, again, it has to be in this form, okay, in slope-intercept form. But this one is not. So what I'm going to do is I'm going to say that 2y equals 4x, but I had a plus 8 here. I'm going to subtract that 8 from both sides of the equation. Okay, so then this is 4x minus 8. And next, I'm going to divide by 2 on each term. So then I have y equals 4 divided by 2 is going to be 2x, and negative 8 divided by 2 is negative 4. So this is, I'm going to graph this one first. So this one has a y-intercept of 0 and negative 4. So that's this point here. Okay, 0 and negative 4. And then it has a rise of 2 and a run of 1. That's the slope, right? So 1, 2, and up 1, 1, 2, and up 1. And I can get as many points as I want. And I'm just going to keep getting more points here, okay? Because this is very easy to do. Okay, then I'm going to connect the points. So I'm going to connect these 2 points, and I'm switching straight edges here. I'm using rulers and my ID. Okay, now let's look at the other equation. The other equation is also 2x minus 4. So what does that mean? See how they look the same? So what can we say in this case? How many solutions does this one have? Okay, so if I graph this one, it's going to be the same line on top of this one here. Okay, so it's going to be the same line. So then we say that this one has infinitely many solutions. Okay, because we have the same line. If you have the same equation, then the line is going to be the same for both equations. Let's see what else. So we have something like this. It's a consistent because infinitely many solutions, and dependent. Okay, and this one is consistent and independent because there's only one point of intersection. All right, so let's go on to the next 2 examples. But on these 2 problems, we are going to use a table to solve a system. Okay, so I'm going to first I got to set this both equations in slope-intercept form, and as you can see, I have 5x plus y equals 11. So I'm going to subtract those 5x's from here and here. So then I have y equals negative 5x plus 11. And on this one here, this one I have x minus y equals 1. So I'm going to subtract this x. So that leaves me with negative y equals, this x becomes negative on the right hand side because I subtracted it. And then I'm going to add 1. Now, we don't want negative y, we want positive y, so I'm going to divide by a negative 1. Okay, so then y equals, in this case, it's going to be negative x divided by negative 1. It's going to be positive x, and 1 divided by negative 1, it's going to be a negative 1. So this is one equation, and this is the other equation. Now, this is how we use the tables. Okay, so I'm going to set up a table, and since I have two equations, and what we're trying to find is where the line intersects by using a table. So then we have x values, y values, and we have two of them, right? Because we have two equations. All right, so what I'm going to do is I'm going to just play with numbers here. Okay, so I'm going to start with 0 here, and I'm going to leave some space in case I need to use negative values. So watch. I'm going to plug in a 0 here. So when x is 0, this one is negative 5 times 0, it's 0. So y on the first equation is going to be 11, right? And then I'm going to do the same thing with this equation. When x is 0, the value of y is 0 minus 1. So this is negative 1. Okay? I'm going to try another value. Okay, I'm going to try 1 next, which is the next value on the table. And negative 5 times 1 is going to be negative 5. Negative 5 plus 11, that is going to be 6. Okay? And then I'm going to do the same thing with this one here. So when x is 1, 1 minus 1 is 0. So far, I'm not there yet. I'm trying to find a point in which the x value has the same two y values. Okay, so I'm going to get closer to this next. So the next number is going to be 2, or next value is going to be 2. So negative 5 times 2 is negative 10. Negative 10 plus 11, this is going to be 1. And then 2 minus 1, that is a 1. And as you can see, when x is 2, I get the same y value for both functions. So that tells us that the solution to this system of equations is 2 comma 1. Okay, so there is a solution. Again, just find the value of x that gives you the same y value in both y's, okay, for the two functions. All right, so let's do the same thing for this one here. And again, check that this is in slope-intercept form, and this one it's not. So I'm going to, again, I have x plus y on this one. I'm going to subtract the x, okay, so minus x and minus x here. So then I have y equals negative x plus 6. That's one equation. And the other one, I also have, on this one, you know what? I'm going to bring the y, no, let's do the same thing we did here. So I'm going to, let's see, I'm going to subtract the x, okay, so minus x here and minus x here. So then I have negative y equals negative x plus 4. And then I'm going to divide by a negative 1. So that gives me y equals x minus 4. So this is one equation, and this is the other equation. And so these are the two equations in the system of equations. All right, so the same thing. I'm going to set up my table. Okay, so I have my table of values here. This will be the x values, y value, and y value here. Okay, so let's start again with 0. Okay, and I'm going to do 0 somewhere here in case I need to use the negatives. The negatives are going to be here. So when x is 0, on the first equation, y is 6, right? When x is 0 on this one, y is negative 4. So those two don't match, so that means we got to move on to the next value. So let's do 1. If x is 1, negative 1, this becomes a negative 1 plus 6, positive 5. Negative 1 minus 4, this is, this will be negative, I said negative 1, this should be 1, right? So this is 1 minus 4, negative 3. So these two don't match, then we move on to the next value. So let's try 2. When x is 2, this is negative 2 plus 4. Plus 6, this is going to be 4. 2 minus 2, this is negative 2. So as you can see, this one didn't work either. So we keep getting closer, so let's move on to the next value. The next value is going to be 3. So when x is 3, this is negative 3 plus 6. This is 3. And this is 3 minus 4, negative 1. Right? So again, these keep getting closer, but we're not there yet. Okay? So then let's go on to the next one, 4. When x is 4, this is negative 4 plus 6. This is going to be 2. And then when x is 4 here, this is 0, so we're getting closer together. Okay, 2 and 0, we're getting there. And then let's try the next one. So this one is going to be 5. This will be negative 5 plus 6, that's 1. And then this is 5 minus 4, that's 1. And there is our solution. So the solution to this system of equations by using the table is 5, 1. Okay, and there is the last example for today. All right, thank you for watching. I'll talk to you soon. Bye-bye.